Manoj. I am a senior applied scientist in Microsoft AI and Research Division, and so I also happen to be an adjunct faculty in IIIT Hyderabad. So I'm going to be taking a few of this machine learning related classes. So I didn't know today was the first session in machine learning. So I was here to deliver the clustering and PCA class. So and I just came to know that today is the introduction. So I thought instead of directly, introducing you to the topic, so I'll just first, give you a brief introduction about so what is the field that you're getting into, right? So what is machine learning? So and what is the big picture, like a 20,000 feet view of what is machine learning is, and so what are the different sub problems within machine learning. So I'll give you a very brief overview of what is this big field, and then today we'll just deal with one of these topics, which is unsupervised learning. Okay. So this is one presentation I keep giving. So in within Microsoft to folks who are getting introduced to machine learning. So I'm reusing the same set of slides. Okay. So welcome, right, to machine learning. So since this are slides from Microsoft, I only have people who are talking from Microsoft, right? So but this is the same view of other people as well. So and what Bill Gates said is in case he gets to so once again go through computer science, so machine learning would be one field he would read once again, right? If he has a chance to do computer science once again. That's what he said. And any breakthrough in this particular field is worth 10 Microsoft. That's the kind of value this particular space has. Right? So that's the potential it has. I'll shortly show you why there is so much potential in this field. So, okay, so what is machine learning? So, machine learning, you can think about it as automating automation, right? So, automation we all know. So, we've been writing a lot of programs, we've been doing a lot of stuff to automate things, right? So, can we now automate this process of writing programs? That's what we're going to talk about, right? That is automating automation. So in short, if you can say it, so we are going to actually try to get computers to program themselves, right? That's what we'll try to do. So and this is especially useful when writing software is a bottleneck in a lot of places, right? Not so writing software for some particular problems is very hard. I'll just show you why. Right? So what we're going to do is instead of writing the program ourselves, so we're going to actually let the data decide what program it should have. Right? So what program it should get out of it. So will the data decide it? So 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 the traditional programming paradigm is the following, right? So what you do in traditional programming is you have actually you write a program, and so you give data to the program and you get the output, right? So in certain places, so now in the case of machine learning, the paradigm is different. So what you do is actually you give the input and output to the computer, to the machine learning algorithm, and that will output the program. Okay, that will output the program which will do this input to output mapping. That's the sort of change in paradigm with respect to the regular computer programming paradigm. That's one. So let's take a following. So one case study for this. So one case study is the case of handwritten recognition. Right? So let's say so US postal system is already automated completely. So let's say you write an address on some mail. So what happens is this particular address is read by a machine learning algorithm, and actually they do segmentation. They actually figure out what is the street part of the address. So what is the city? So what is the zip code? And the mail gets appropriately routed to that particular based on the zip code. Right? So now, we all know that is a very hard problem because people have different handwritings. People could be writing this in many different ways. So now imagine, so we want to automate this whole process. Right? So how do we automate it? Let's say we want to write a program to identify all sorts of zip codes, all sorts of digits, and all sorts of addresses. Right? So if you imagine writing a program for it, so it's going to be a very hard program. Right? So there are going to be a lot of special cases, lots of different cases, and I really don't know if you can, in spite of handling all those cases, you can really get one program to handle all these variations. Right? That's the hard part of it. Right? So here is a very clear case where the traditional programming paradigm is clearly not viable. Right? So because of the amount of variations we have depending on the humans, and so many variations if we have to actually capture in one single program, so one single guy, it's very hard. Right? So that's where machine learning comes to our rescue. What we do is we sort of so give the input and output mapping. Okay, so we actually give training examples. So we say if this is the input, I want this to be the output, right? and if this is the input, I want this to be the output. So what we do is we give various different ways of writing this digit along with the true digit label that we already know, right? We actually give this mapping, and the machine learning algorithm does the magic, right? So it actually takes this input output mappings and it will generate a program, so which will give us so given a new image, it will actually output the digit that is identified. So that is what it does. So when are we supposed to use machine learning, right? So what is the situations where machine learning is apt? So basically, learn it when you can't code it. So especially, there are situations when we can't really code some things up. But let's say there is a situation where you can clearly nicely code. The logic is very simple, and you can easily code it up. So then probably machine learning is not a good candidate to apply for that kind of problem, right? So wherever you can easily write a very nice code and very deterministic code to finish the task off, so probably you don't need machine learning. You only need machine learning when coding is really hard. Coding some problem is really hard, especially it includes a lot of variations and all that, right? So machine learning is also useful when you can't scale it. For example, there are places where you can write a program, but it's very hard to scale across millions and millions of users. Right? So let's say, for example, recommendations. So I may write an algorithm to recommend a particular item to a particular user. So that program may run very well for 10 users. But imagine that let's say I want to scale the same program to millions of customers like Amazon is doing. Right? So now Amazon is actually surfacing recommendations for millions of its customers. Now, can you automatically write a program which does it? Which deterministic program is pretty hard, right? So because it depends on the input, the profile and the taste of the user, so I have to actually tailor these recommendations, and that means I have to scale it across very many users, right? So a typical program cannot scale itself to that extent, especially because of the variations that it brings in. So that's where machine learning is once again a very good candidate, right? So especially for spam detection, for example, if it's only my mailbox, I can write one or many different rules. So probably I can write a spam detector for my own mailbox using some 10, 20 rules, right, very nicely. But let's say I'm Google and I want to do it across all my accounts, user accounts, right? It's going to be the millions of user accounts, and I want to actually, so how can I vary my rules, right? It's very hard. So then that's when I have to rely on machine learning, right? So because machine learning will automatically depending on each person's input and output mapping. So for one person, it could be an important mail. For the other guy, it could be spam, right? So depending on each person's input and output mappings and variations, so the machine learning algorithm will vary its output. Okay? So that's the advantage we have. And you also have use machine learning when you have to adapt or personalize. So we all have Android phones, and Android phones come with a Swift keyboard, right? So so whenever you do some gesture of the sort, so and it picks up the word that you have, right? So that's going to be very highly dependent on the kind of words you typically use in your mail. Right? Somebody may be using word could very frequently, whereas the other guy could be using some other word which is child or something, right? So given so whatever you swiped in, I have two choices. Should it be the word could or child? Then depending on what your vocabulary is, what is what you use more often, have to personalize the completion based on that, based on your own language, right? So that's when so machine learning is once again useful because so there is one program, but that program is learning based on the habits of individual users, right? So the program is not different, but it's actually getting personalized to each guy differently. So personalization is once again a very important scenario. And there are other places like AI gaming and robot control kind of things where it's very difficult to sort of so keep track of all the states that the particular machine is in, right? Let's say, for example, in the case of robot arm movement or robot movement, you cannot write a program saying, if you are in this state, do this kind of a thing, right? So because the number of states is pretty large, so it has to be, driven automatically depending dynamically on the situation, right? It cannot be, a fixed number of states. So these are the places, these are the general guidelines. And so let's say, for example, you already know some knowledge, you should not be really using machine learning for that, right? So if you can easily, use web to crawl that data and get that knowledge, you should not be redoing whatever is already available. That's also one more guideline. So don't learn what you already know. So that's the guideline here, right? Okay, so initially it may sound like magic, right? So all of it, what you give input, output, it learns by itself. So how is it going to happen? This all sounds like magic, but but not really. I mean, you can't. So if you look at it, it's more not like magic. It's more like gardening. Right? You can compare machine learning. So because you still have to give good seeds, good nutrients, you have to be a good gardener. Right? So here the seeds are algorithms. You have to make the right choice of algorithms. So what is depending on the problem, what is the right choice of algorithm you have to pick, right? And you have to supply right nutrients, right data. I may have the world's best, most smartest algorithm, but if I don't have the data for that, so then it's going to be of no use, right? So because the more input and output samples I see, the more smarter I get, right? So one example I typically give is if you actually imagine yourself using Google in let's say 2002 or 2001 when it was initially conceptualized, there were many times when Google used to actually return us results in the 8th and 10th page. Right? So and what did we do? We actually painfully took that and went to the 8th page and 10th page and clicked on it. Clicked on the right result, and that's how Google started learning. Right? So we all gave Google cumulatively. We gave Google the knowledge that it has today. So today, whatever Google is because of the knowledge that it has, because of the data it has, not because of the algorithms. Right? So algorithms, you and me can also read a few good research papers and write one of the smartest algorithms. But what Google has is it has the cumulative knowledge of the entire world in some sense. Right? Every day we go and give a query, and we also tell Google what is the right answer for that. We don't go and click on it. If I give you 10 answers, you never click on the wrong answer. You're only going to click on the right answer, right? And that's when it starts learning. And so next time you give the same query, it's going to actually show it up at the top of the list, right? So data is very very crucial. And in machine learning, the traditional wisdom is that so more data trumps clever algorithms, right? So basically, if you have only 2 hours, so you have an option of coding up a very clever algorithm and going and collecting data. You better go and collect data, right? And use a simpler algorithm. So that's the kind of typical wisdom. Okay, so it doesn't mean you don't have any work to do. So as a data scientist, it's a good thing. So we have a job, right? So because if it's entirely magic, we will be unemployed, right? So we still have job in the sense we have to pick the right algorithms, we have to pick the right data, we have to model the problem correctly. So give it the right training and everything. So where is it applied today? So it is applied at a lot of places. So some of the things that we are very very aware of or every day keep using is search. So for example, today I search for Eat India company. Okay, and I search this in some other place like so where there is this restaurant, famous restaurant called East Eat India company. That restaurant is not there. So probably let's say I do it in some remote place in Andhra Pradesh. Then it corrects, does spell correction and does and gives me results for East India company. Okay. So whereas if I do it in Hyderabad today, so it gives me a restaurant Eat India company which is located somewhere here. Okay, so that's the smartness that it has. So this we all typically we are aware of it. We are every day using it, but there are a lot of places where it's currently started making a big impact, and it's on the horizon. So for example, online speech translation is something which is so it's a big thing now. So wherein so we are now at a stage where we can recognize speech automatically. We can convert that speech into a string of words, and we can even translate those string of words into another language and translate that into speech, right? So here's a demo of Skype translator. So what Skype online translator this demo does is actually they connected two schools. So one school in Seattle to another school in Mexico, right? So this kid she speaks English. This kid is speaking Spanish, and they connected both of them. So this is so this is what it is online translated, getting translated. Right? Okay, so this is where, so one of the places where it's being used, so online translation, so it's a completely, so outcome of the advances in machine learning, right? Especially in the speech domain, machine translation domain, natural language processing domain. So I just want to give you one more example where, so just to show that it's being applied in places where we can't even imagine, right? So dairy farm industry is one industry where it's being heavily used now. So basically, so in all these dairy farms, it's pretty important to track. So the various states in which these, there are very few people in, especially in Western countries, so where these dairy farms are being maintained. So they don't have so much manual labor, so they have automatic tracking devices to figure out, so what are the various states in which this, cattle are, right? So especially one thing they are trying to automate is, so when are they supposed to breed cattle, right? So cattle breeding is extremely sensitive because it depends on a particular hormone that the cattle secretes, right, at that point of time, and that's when you're supposed to inject artificial insemination into the cattle, and that's how the cattle breed. So if you don't get the time of the hormone secretion correctly, so it's not going to breed, right? So now it's extremely important to figure out, so when is a particular cow going to actually secrete this particular hormone, right? And that's where people have tried using data science. So I mean, this is how big the farms would be. So it's pretty hard for humans to track all the every individual cattle, right? So what they did is they actually gave devices like this. These are like pedometers kind of devices. So they actually tied them to cattle, and they are now using data science to actually figure out the correlation. This is the number of steps the cattle takes at a given time of the day, right? And they found a very strong correlation with the number of steps it takes when the hormone is secreted. Right? This is how the number of steps increases suddenly, right? And that's actually the point where if you start inseminating it, then so exactly if you inseminate at that point of time, so 16 hours later if you do it, then so if you do it at the first part of the time, you get a female cattle, a female, or later if you get a male, right? So you can even control the gender, so depending on data science, right? So using data science, so that's the level to which the industry has gone, right? So this is typically called, so AI is artificial insemination. So AI is artificial intelligence. So AI meets AI, right? So this is one example where dairy industry is using it, but it's not just dairy industry. So so the industry is expanding a lot. So especially it's being used in this Internet of Things. So everywhere there are smart devices. So you have your smart watch, smart. So you can in the latest BMW, you can actually ask your car to park itself. Right? Say go park yourself, and you go and park itself. Right? So it's fully Internet of Things, which means so everything that, so there are two sides to this particular industry. So there is the consumer side where we all use a lot of wearables, right? So our phones, smartwatches, and whatnot, they all have this ability to process data and generate data and get trends based on it. For example, based on your smartwatch, I can figure out which state you are currently in, right? So are you currently sleeping or in active state, or which state you are in, right? So similarly, there is the other side, which is the industrial side as well. So where people are trying to automate a lot of different things. Right? So for example, your cars, electricity grid. So you must have all heard about smart cities, right? A smart city is a large part of it is about automatically allowing devices to control a lot of things that the humans control. And what is the value of this industry? So this industry is pretty valuable. So this is, at least by any estimate, the conservative estimate that I'm giving, that in each industry, if you use these technologies to make 1% saving, right? So for example, you can use machine learning to actually save fuel in the aviation industry. And if that makes 1% impact, this is the amount of revenue you're going to generate out of it. So typically, in power generation, healthcare, there's a very big scope. So for example, there are a lot of new startups which are trying to, predict what is the probability of a patient getting readmitted because of any disease. Right? So typically, what happens is the hospital discharges them, but because of due to certain things, the patient gets readmitted. Right? He has a probability of getting that disease once again. So if you're able to rightly predict that, it can save a lot of costs for the patient and the hospital as well. So a lot of patients doing that in healthcare. So there's a lot of stuff. So rail freight transport industry, there's a lot of value out of it. So yeah. So I mean, this is the so big 20,000 feet overview of that. So let's get a little more deeper. So and just try to see what are the big paradigms within machine learning. Right? So within machine learning, so there is one paradigm. So this is the, let me show you the big overview picture. Then we can zoom in. Yeah. So this is the classification of machine learning problems. Okay. So what we have is so machine learning is mainly divided into two paradigms. So one paradigm is supervised learning, other paradigm is unsupervised learning, right? So in the case of supervised learning, what you have is so there is, you're trying to predict something. So this is mainly predictive analytics. So in your given business problem, you have something that you're trying to predict. Either that could be a discrete variable or it's a continuous variable. Let's say you're trying to predict whether you should be giving loan to a customer or not, right? You're a financial bank. You're trying to see if you should be giving a loan to a particular customer or not. In that case, it becomes a classification problem, right? So let's say, or on the other hand, you're trying to predict the rates of real estate at a particular area, right? Let's say I give you a particular area called Medipattam or whatever. So then you have to give me what is the average rate, real estate rate there. You're trying to predict. Or let's say I give you a totally new area where there is no construction. So depending on the previous demand and stuff, you have to predict. So what is the likely rate they're going to be? So these kind of problems fall under supervised learning. And in supervised learning, the main thing is that you already have access to training data in the form of historical data that you have already stored or whatever, but you already know, you already have data that you have stored for which you already know the ground truth. Right? So let's say the bank wants to actually learn a model to decide whether they should be giving a loan to a customer or not. So probably the bank has already stored some historical data. So wherein they have access to data where they had previously given loan to some people and whether they had returned the loan or not, they have stored that data as well. Right? In this case, the class label you're trying to predict, either whether it is a continuous variable or whether it is a discrete variable, you already have data where you know the ground truth. Right? You have stored it in some form, and you're going to actually use that to learn the model. That's the big difference here. So within supervised learning, so if the class label you're trying to predict, if it is a discrete value, so 1 out of k possibilities, it is called classification. So if it's 1 out of k possibilities, it is called classification. And whatever you're trying to predict, if it's a real number, it is called regression. So one example for regression is, let's say I'm trying to predict stock market prices. So then the prices are real numbers. So that's called regression. Right? The target is always this thing. And there are some problems in which the prediction that I do is a sequential prediction. Right? So here is one example. So given a particular sentence, I want the parts of speech tags for that. Okay. So which means for every word I have to classify each word into one of the parts of speech. Whether is it a determiner, is it a verb, is it a noun, or what is it? Right. So this is for each word it is a classification. The difference is that this classification is a sequential classification. Right. So it's a chain classification. So one choice of label I make will determine the next one as well. Right. Because there is a co-occurrence relationship between these labels also. So that's the reason it is a special case. So one more example here is, let's say I have given you a complete address that some user has written. You have to actually segment that particular address into multiple fields. Right? This is the house number. This is the street name. This is the colony name, street name, and this is the city name. This is the state name. This is the zip code. So given a particular address, you are supposed to segment that into or tag that with the corresponding field of the address. Right? How do you do that? So that's also a sequence learning problem. Sequence learning problem, like I said, is a sequence of decisions that you make, right? Sequence of predictions that you make. That's the main difference. So coming back to this, there is unsupervised learning. So in the case of unsupervised learning, so what we have is we don't have any labels. Okay? We just have data. So there is no one label that you're trying to predict. There is no prediction task. But what is the difference? The difference is that the task is more exploratory. Right? So what you're trying to do is you have given this data, you're trying to actually figure out what are the different subpopulations in this data, okay? And what are the characteristics of this data, how is this distributed. For example, a company may want to actually look at so the different profiles of its customers. Right? So what are the different classes of customers who are visiting me? Right? So for example, it could be professionals, it could be school like students, it could be homemakers, a lot of these things. So profiles, and the company wants to understand. So what is the distribution of each of these classes? So how big is each of this subpopulation I'm getting? So at what time of the day they're visiting and all these things, right? So this is a typical example where there is no one single label you're trying to predict. but rather what you're trying to do is you're trying to do exploratory kind of stuff, right? So given this data, you're sort of zooming into the data, zooming out. You're trying to get different views of the data, you're trying to figure out what is the population, you're trying to group data in different ways and check, right? So that's so within unsupervised learning, there are two major techniques. So one of it I'm going to cover today is clustering. So which is grouping of similar things. Let's say I give you 10 objects. So can you group these 10 objects into similar objects? Right? Three groups of similar objects. That's the grouping task. We humans are very adept at doing it, so we do it very naturally. So but so how can a machine learning algorithm automatically do it? So that's the whole problem. So let's say I'm Amazon, so I give it all catalog of items that I have. So I give it to this algorithm. Can the algorithm automatically group it, saying these items are electronics, these items are consumer goods, these items are all different products, right? So can it automatically group things like that? That's what clustering is about. Yeah, yeah. Yeah, yeah. No, no. So because here, although, so let's say once I give you the groups, you may label the groups also. Let's say, for example, I give you all the groups of customers. You may say, identify, okay, this group, what, this group is actually the professionals group. You may even tag that group. But what you're not doing is you're not trying to predict the group. So let's say, given a new point, you're not trying to, for that new point, predict which group it belongs to. Right? If that is the case, then it falls into supervised learning. Then you have to build a model to say for this new point, if I have to predict this model, so what is it going to do? So that you have to do that. Okay, so that's the crucial difference. So in case if you're doing any predictive stuff, that goes here. Okay. So what may happen is you may actually find out the group, identify the group, tag the group, and then train a model as well. Right? So then it becomes initially you did unsupervised, then you went into based on your knowledge, you gave some labels, and then you went into shifted to supervised. That's how it is. Okay, so today I'm going to cover these two, dimensional reduction and clustering. But what is important in general in machine learning is to generalize, right? So basically, so it's not important for you to do well on whatever examples you've seen so far. So what is important is so what are we humans good at? We humans are good at, so what I give you, let's say, training on a particular task. So let's say I teach you some 10 problems, 10 mathematical problems. So if you just solve those 10 problems only, so it is not a big deal, right? So I don't say that you have really learned the concept. Right? So when do I say you have learned the concept? Let's say I give you a new problem, which is not amongst these 10 problems, and you're able to successfully solve it, then I say that you have really learned the concept. Right? It is exactly the same case with machine learning as well. So the crucial thing here is to generalize beyond the examples that are there in the training set. So and there are two, three different cases there. So let's say I give you the training example. So like this. So here I'm trying to distinguish between red and green points here. So in one case, you may not actually fully learn the whole concept. Right? So here the ideal concept is much more, involved, like this. So it didn't learn it perfectly. So that is called underfitting. Right? So it is insufficient. So it has not learned completely what has to be learned. There is still something to be learned, right? That is underfitting, right? In this case, this one has overdone it, right? It is for example, it has tried to learn more than what is there. So it has unnecessarily complicated this whole pattern. So this is called overfitting, right? So both of this is bad. So what is ideally needed is the right amount of generalization, right? So that you don't pick too much noise, which is given in the training data as well, and you also don't do lesser learning, right? So this is the model building process typically. So you're given some data, and so for which the results labels are already known. For example, let us say I'm trying to do classification between positive and negative. Taking examples, let's say this is the same financial bank, so whether a loan should be given to a customer or not. So positive means loan should be given. Negative means loan should not be given. Let's say I already have this kind of historical data with me. Then part of that data I take it as training data, right? And part of the data I take it as validation data. So why am I doing it? Because I'm just doing it to test the amount of generalization the model does, right? So if I test it on the same set every time, then it's not a big deal, like I said, right? In order to truly test the generalization, I have to test it with some example outside of this training set. Right? That's what I'm trying to mimic here. So instead of giving all the data for training, I'm actually taking some of the data for training for model building, and some data for testing how well it does on some unseen examples. Right? So this is how I distribute it, and then on this training set, I build a model, and then I evaluate this model. Right? So how well is the model doing on this validation set, and I may do a little bit of tuning. Right? So every model, remember, has some tuning parameters. Right? So every model comes with some knobs that you have in your hand. So as a data scientist, you can actually tune those knobs to move it to make it move in either direction. Right? So if it's underfitting, you can actually tune that to move towards overfitting. You can actually overfitting to move it, make it move towards this underfitting thing, right? So you can make those tunings on the validation set, and you also keep something as a test set. The test set is something that you only test and you don't debug on it, right? So this is just to avoid overfitting on this particular data set, right? And you report your final evaluation numbers on this test set. So this is the typical model building paradigm that you have in machine learning. And this is the model building process as well. So I think I'll stop here because the rest of it will once again summarize when we take an overall view. So because what I typically do is after all the lectures finish, we'll once again do a recap. So wherein we'll actually look back on what we have learned, and so how are things done in industry. Right? So this is the model building process. It all starts with the business problem. So you have some business problem so in your organization that you want to solve, and you actually what you do is you map that business problem to a particular machine learning problem. Okay? So let's say so in my organization I have yeah. So this is like I have this problem. We have to identify who are the right people to lend money to, right? Or let's say I'm a credit card company, so I'm frequently encountering some loss because of fraud transactions. Right? So now that's where the business problem starts, and it has some very big impact that the organization is getting. So can you stop this particular thing, right? That's where the problem starts. So now you map that particular problem as a classification problem, right? So identifying a fraud or not fraud is a classification problem. So now it starts with extracting data. So like I said, so the crucial part of the whole this machine learning cycle is extracting the data, right? So now if I want to solve this problem, what is the data that I want? Right? And without data, machine learning is nothing, right? So now you go, you check your historical data. So do you have already data with some or labels present with that where you can use identify it? So you curate the kind of data, you clean it, you do all of that. So typically this process is very non-trivial and significant amount of time goes into this. So one may imagine, one may have a very romantic imagination that like as a data scientist I may be only doing modeling, right? 70%, 80% of the time is modeling. It's not that. So 30-40% of the time goes in this process. So defining the problem clearly, getting the data, cleaning the data, massaging the data, getting it to the right format, right? So all of that dirty work is 40% of the work. So then this actual model building process is probably 30-40% once again. Right? The rest of it is deploying, learning from it, incorporating the feedback. That's how the whole game is. So this is the big picture. Then you develop models. You go through multiple iterations. So then you deploy the model online. So you have some feedback metrics that you have, right, based on which you performance feedback metrics that give you feedback on how well the model is doing, because you have trained it on something. Now it's actually encountering real world data. That's where the real test is. So whether is it passing that test or failing that test, and based on that you retune the model once again, right? So to go back to the business problem, go back to drawing board. Did I do it correctly? So what was it wrong? So this is the whole cyclic process, right? So any questions so far? This is like the big overview. So we'll now zoom in into clustering, right? So unsupervised learning. So any questions on the overview part? So don't worry, we'll actually, once we finish it, we are going to revisit this and do a recap sort of a thing on what we have learned so far. But till now, any questions? Web crawler is not really in any of these categories, right? But it's not doing any machine learning. So what a web crawler is doing is it's going to the web and getting data. That's it. Right? But web crawler may involve certain certain things. Right? For example, if a web crawler decides not to crawl spam, right, that's when the web crawler requires intelligence. Intelligence of given a particular page, is it spam or not? That's how it is, right? Then there is a little bit of machine learning. Okay, so now I'll start with clustering. So what I'll do is, so I'll first cover what is unsupervised learning. Okay, then I'll first talk about hard clustering. Right? So hard clustering is assigning every point or data point to only one single cluster. That is hard clustering. They made a very hard decision. Okay. Then we look into hierarchical clustering. Then next I'll explain soft clustering, which is every point can belong to more than one cluster. Right? So both parties you can belong to, right? So then I'll talk about one paradigm called spectral clustering. And then I conclude it. Okay. Okay. So I'll just explain the business case for why clustering is required, right? So let's say I'm a carpet manufacturing company. So I want to manufacture carpets. There are two dimensions in which I can vary my carpets. Okay? So either I can build carpets of very good strength or low strength. Strength is whether it can break easily or not, right? The other thing I can vary as a product quality is so how water resistant it is. It has low water resistance or high water resistance, right? So now if I have limited budget, I have to decide which of this I'm going to build, focus on, right? In the market, there could be demand for many different things, right? So all the combinations are possible. So let's say in strength it is low and high, and so water resistance it is low and high. Right? So now I have to figure out that market has many different subgroups, right? So if I want to make my carpets, so which group am I targeting? So and I have to make my product tailored to that particular group. Right? So the first thing is I have to actually study the market. So what is studying the market? So basically I have to go to the market and I have to actually ask people. Let's say you want to, so I want to sell you a carpet. So what is your preference? So would you prefer strong carpet with very high water resistance, or would you prefer, which of these parameters would you able to prefer? So let's say I went to the market, I studied all of that. Right? So I went to every particular organization, I asked them this particular question, and then I actually plotted all of this data. Right? So now, so what I have is I have two feature values. So this is the data I have. This is data sample 1. So I have strength and I have water resistance. Okay. So this is, let's say, strength can take low or high, so L or H, and water resistance can also take low water resistance or high water resistance. Right? So like that, I have data points collected, many different data points from many different people. So now what I want is I want to now group this data into multiple subpopulations. Okay? So what I want is I want to group all the people who think alike, and I want to identify who are these people. Okay, so let's say the data could be something like this. So this may be one particular group, right? They all have similar perceptions about the product. Okay, so this may be one particular group, so they all have similar perceptions about the product, right? Desired product. Okay, this may be one group, and now how do I group these people? Right? So given this data, how do I group it into multiple groups? Let's say I want to say that out of this data, give me 4 groups, right? 4 strong groups. So now I should be able to actually say these are the 4 strong groups. Right? Because all of this happens automatically, right? So this, how can you group things? So and then I can go and actually I can zoom in one particular group and I can say, okay, this looks like these all people are schools, right? So all schools seem to be having one requirement. Okay, so all health clubs seem to be having one requirement. Right? So all commercial kind of people seem to be having one kind of requirement. Right? This is what I can identify, and I can also study what the competition is doing. Right? So let's say competition is already targeting one of these groups. I can say, no, I don't want to target A, D, and C. I'll only target B. Right? So whatever budget I have, let me put into building low water resistance and low strength carpets, which are very cheap. So let me actually push to that kind of a product. Right? So this is typical market segment analysis that happens. So as part of market segment analysis, what you do is you go to the market and you collect lots and lots of data. So from your various customers, and then you actually sort of group all these customers together, and that's where clustering comes into picture. Because when you collect this data from the market, you will have data of this form. So every data point will have multiple attribute values that you have, and there is no target label that you're trying to predict here. There are just attribute values, and what you ask the algorithm is, okay, so given this is my data, you please give me the most strongest groups out of this data. And now once the clustering algorithm groups this and gives it back to me, so what I can do is I can actually go and look up in each group and identify what each group is. And I can go and zoom in and I can say, okay, this seems to be schools, this seems to be hospitals, and that kind of thing. And then I can take the appropriate action. Right? So is this clear? This is the problem of clustering. Okay. So automatically discover what is the task. Automatically discover the underlying structure in the data. Okay? That is the challenge problem. And what is the challenge? There is no training data available. You are not given any training data. So okay, so what is clustering? You can define clustering like this: grouping objects together based on similarity. Okay, you have to group objects, and because it is unsupervised learning, you don't have any predefined classes. So because you don't know, it's completely exploratory, right? You don't know how many classes are there. So, but this is the problem. Sounds like a very vague problem statement. Why? Can somebody tell me why? So let's say I ask you to group this bunch of objects. Huh? Yeah, okay, but what is the problem with this statement then? Grouping together based on similarity? Yeah, you're saying. What kind of similarity, right? It could be gender, like you said, it could be gender. So like let's say I asked you to group these items, you would group it on gender. Somebody else would actually group it on the color of the dress, right? So like that, so there could be many different groupings. You know, somebody would say so group it males and females, right, based on gender. Somebody would say these are all Simpsons family, like somebody would say these are all school employees. So given the same data, I can actually come up with multiple groupings. So the grouping need not be unique, right? Right? That's where the vagueness of the problem comes in, and that's where the subjectiveness is well. Right? Let's say I give you the same group of objects to two different people, they're going to actually group them in two different ways. Okay? That's subjectiveness. That's where it's coming in, and that's the reason it's a little vague. So and now the kind of clustering you would get is based on the kind of similarity you define. Right? So now it depends on how you define the similarity function between these two data points. Right? So if you use one distance function, you would get one clustering. If you use a different distance function, you would get a different thing. And that's why the domain knowledge is extremely important. So you have to appropriately choose the right distance function, right? And check whether that distance function is giving you the right bunch of items, right? So what is the objective? A good distance function should put two similar things together and two dissimilar things apart. That's what it should do. So it should bring two similar things together, two dissimilar things apart. Okay? So that's what you will initially pick the distance function based on that, and that's when you apply the clustering algorithm after that. Right? Okay, so what is the, I think classification you have not done it. So okay, but clustering is so there are many possible it's unsupervised, and so we looked at generalization, right? So in the case of supervised learning, generalization is very important. In the case of clustering, generalization is not the one which is important. What is important is your performance on the current data. Right? In the case of classification or some things, what it is important is I have given you training data, but on unseen data, what is the performance, right? In the case of clustering, it's not that. So there is no unseen data. So whatever a data I give you, the performance on that data is what is important. Okay? And what you don't know is you don't know the prior number of clusters which is present. Okay, that is you don't know. And the goal is not prediction, the goal is exploration. Okay? An exploratory mode. Okay, so one very simple algorithm for doing clustering is an algorithm called k-means. Okay, so let's take a look into what k-means does. So can someone tell me what is the, let's say I want you to group this into two groups of points, right? So how will you do it? So just select, use the mouse and select. Okay, nice. So let's say machine learning. Think in terms of below zero. Very good. Very good. Below zero, above zero. But let's say you want to use How do you know that all the points are below 0? All of them. So I want an algorithm. So I give you, so all these points, in every point, let's say there are two feature values, right? So one feature attribute value is this feature 1 and feature 2, x and y, right? For every data point, you have two feature values, and I give you so many data points, right? So you have a, think about it as you have an array, right? Now you have to group this array into two parts, right? Two clusters, two groups, such that all the points belonging to a single group should be more similar within than points outside the group, right? So for example, according to this definition, so this point belongs to this group or group 1, because this point, if I assign to this group, then it will be much dissimilar. So it's more similar to this group than this group. Right? Now, how do you, so visually you can easily see that this is the group of points and this is the group of points. So we have a very strong clustering algorithm inside our brain that is automatically doing that job. But if a machine has to do it, right, so how will it do it? Because all a machine sees is it just looks at an array of so many points. Let's say there are 25 points or 30 points here. So it looks at an array of 30 points each with x, y values. Right? Now, how will an algorithm do it? Calculate the mean. Very good. Okay. Uh-huh. Okay. So calculate. So how many means? Two means. Okay. Okay. So what he's saying is calculate two means, but means of which points? Then it will be only one mean, right? To calculate means of all x's and all y's, it will be only one mean. You want two means. Huh. No, we have not divided. That's the problem itself. Huh. That you are able to visually see, so you are directly defining 0, right? But how do you know it is 0? Okay. Huh. Okay. Kind of close, very close. Let me give you, this is a very simple iterative algorithm, very, very simple basic iterative algorithm. So what it does is, let's say you already know that you want to actually divide it into two groups, right? So what you do is you randomly pick two centroid points, right? A centroid point represents the whole group. Okay? So this, let's say I want to divide this into blue group and red group. Now I'll randomly say my red group will lie here. This is the centroid of my red group, and this is the centroid of my blue group. I randomly pick the 2 points. Right? So now what I do is, once after I pick these points, what I do is I assign each point to either the red group or the blue group. Right? Every point now I say you have to decide whether you want to go to the red group or blue group. So now how will they decide? Depending on the distance. Right? If a point is closer to this blue centroid, it will go to the blue group. If a point is closer to the red centroid, it will go to the red group. Okay? So let's divide that. Okay, so we have divided. So all the points, every point we assigned them into two different groups. So one is the red group and one is the blue group, right? So now after that, what we do is, let's say all the red points, right? These are the red points. Based on these red points, we once again update this centroid. Because this centroid we initially chose randomly. Now we have assigned this point. Once again, based on the assignment of the point, we will recalculate the centroid. And once again, based on the assignment of the blue points, we will recalculate the blue centroid. Okay, let's do that. Let's see what happens. Centroids have changed. Okay, now because centroids have changed, once again I go back to every point and divide the points into blue and red. I'm doing it iteratively, right? So now once again I go back to every point and say you go to red or blue. So for example, where will this point go? Blue, right? It's closer to blue. Okay, so some points will change their side. So let's say for example this point. This point was earlier belonging to red side, but now what will it happen? What will happen? Blue. Why? Because now it's closer to the blue centroid, right? So this changed the place. Okay. Now because points have changed, once again what I will do? I will update the centroid once again. I'll update the centroid. Centroid has changed. Once again reassign the points. Once again centroid has changed. Okay. Now the grouping is perfect. Clear? Yeah. Random. Completely random. Randomly I chose this one. It could have been here also. Random selection. Uh, Correct. So what do you say? So these people are asking. So is there not a chance of making an error if I randomly choose something? So any, what is your opinion? Correct. Is it always guaranteed that you go get to the right group? See, it's not guaranteed. So what, that was a very genuine concern. So what might happen is because I chose some things randomly, sometimes it may split it wrongly also. Okay. So we'll actually come up with solutions for that. So initially this is the basic algorithm. We'll try to fix the problems in this algorithm. Okay. But that is definitely an issue. Right. Right. Okay. Yeah. So when do you know when to stop, right? So whenever the assignment of the points, every point does not change, and whenever the centroid does not change, right? So now once it converges here, no matter how many times I do this, no matter how many times I do this, the points are always going to be red and blue, and the centroid position will also not change. That's when I'll stop. Or I will also have a maximum iteration, maximum number of iterations loop count, and I'll just stop when the maximum iterations are reached. Right? These are the two conditions. Okay. So is this clear? The stopping criteria? Yeah. Please. Yeah. Hmm. Calculate leverage. Okay. 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 You're saying for every point, calculate all the distances, right? So all the n square n distances, and then if it's less than, so all this. Okay. See, that's also one way of doing it. That's also one way of doing it. So there are many different clustering algorithms. Right? There are many. So I think if you look at the number of research papers on clustering, it's like too many. So you can also come up with your own clustering way of grouping. So this is one popular way of doing it. So there could be other ways as well. We'll come to that. Okay. Yeah. So this one is K-means. It's very popular. It's very easy to implement as well. It's very because all you have to do is the centroid updation step, the distance calculation step. That's the only thing, and that this typically does a very good job. Okay. But the problem is that, let's say, what happens if the clusters are not separable sometimes, right? So here in this case, the groups were clearly separable. This was one circle, this was one circle. But there are cases where where do you actually define one cluster is not clear. Right? So let's take the following example. I want to actually manufacture T-shirts. Okay. So now T-shirts have so different sizes. You have to have a S, M, L, XL, right? So now how small should be S, how big should be L or XL? Right? How do you decide that? Because people have different heights and weights. So how do you decide the sizes of T-shirts? So this is a typical problem where once again clustering is used. So this is the you measure the height and weight of people. It's going to be actually continuous like this. So out of this, you have to draw three clusters, right? And so even for this, k-means is will apply. So depending on how many clusters you want to seed in, you define the appropriate k, right? So let's say you want three sizes, you give k is equal to 3, it will actually group this into three kind of groups. Okay, and you do that, and then what you do is you sort of, after that, how do you decide the size of the shirt? Let's say I come up with three groups. Yeah, so it's centroid, you target that, so you make a particular shirt for that center guy, and leave some margin for other guys also to fit in. So that's the way you do it. And in case you want a very perfect fitting, you have to increase the clusters to make more and more specific kind of. Okay, so I mean, although this K-means algorithm, which sounds very simple, so it can do a very good job. So, for example, this is the case study of image segmentation, right? So, in image segmentation, the problem is you have to identify all the pixels with the same color, with the same color texture, right? So, where is this useful? Let's say you're using a software like Photoshop. Sometimes what you do is you want to actually replace this particular segment of color, and you want to actually add your own color here. Right? Many times you do that. So many times you may have seen that people just change the hair colors. They just want to select the hair of the person from the image. So then, so the Photoshop will exactly select the hair. Right? So how is it doing it? Because it is actually grouping all pixels based on their RGB values. So based on their texture and color values. Right? This is where image segmentation is useful. And if you do this kind of a clustering, this is how kind of segments that it arrives, right? So these are all k-means segmenters. Using a k-means segmenter, it is identified that these all belong to different clusters. Okay, so let's look into the mathematical objective of k-means. So what? Let's pose k-means as an optimization problem. So you guys have studied optimization, right? I mean, in basic introduction. Optimization? Not yet. Okay, good. Okay, so it's very basic. So what I'm introducing, and you'll actually know what is the reason I'm introducing this, because this is one condition that we'll use on later. Right? So what is the job of objective of doing clustering? So let's say I have m data points I want to cluster. So data points are as following: x1, x2, and this is, and I want to cluster each point into one of k clusters. Right? So let's assume that I want to cluster each of them into k clusters. Then the problem is following, that for every point, so the value of ci, it stores which cluster point xi belongs to. Okay. So let's say the first point, it belongs to the third cluster. Then c1 will have a value of 3. So let's say the second point, it belongs to the fifth cluster. This will have a value of 5. Okay. So every point will have a value from 1 to k, between 1 to k, which actually denotes the cluster that particular point belongs to. Okay. Now the problem of clustering is as follows, and I also have, depending on this assignment, I can calculate the centroid of each cluster. Okay, if there are k clusters, I'll have mu1 the centroid of first cluster, mu2 as the centroid of the second cluster, and mu k as the centroid of the kth cluster. Right? These are centroids. This is cluster assignment. And these are actual data points. Is this clear? Okay. So now mathematically, what is the problem, right? So given this particular, given these data points, I have to guess or I have to actually assign the values of clusters to data points. Right? And when I'm assigning it, so in how many ways can I assign clusters? Each data point k ways, but the entire data set. Each point is k times, right? So I have m data points. M into k power m, right? Because every point can be assigned in k ways. This can be assigned in k ways, k into. So yes, this is k power m ways. So I can cluster m points into k clusters in k power m ways, right? Now I have to choose out of all this, what is the best assignment? How do I choose the best assignment? Based on this criteria, right? So the every point should be as close to the cluster centroid as possible. Okay? The average distance of each point from its cluster centroid should be as close as possible. If it is not the case, then it is a bad assignment. So I'll show you, for example, in case you have assigned this point to this cluster listed.